Hello and welcome to MyScience Tutorials. In today's video, we are going to be looking at the acid catalyzed hydration of alkanes. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's go ahead. So let's have an alkane here, then we add water to it. Okay, in the presence of an acid catalyst. So what do we get? So alkanes react with water in the presence of a strong acid catalyst to form an alcohol. So it means when we react an alkane with water in the presence of what? A strong acidic catalyst, we produce what? An alcohol. Okay, so we have an alcohol as our product. Okay, this is our product. Okay, now remember, you can see I use the reversible sign over here, which means the reverse is possible. Okay, so if we have an alkene reacting with water to form alcohol, this reaction is what we call hydration. Now the reverse is what we are calling what? The dehydration reaction. So the dehydration is simply an alcohol. Okay, so if we have an alcohol in the presence of what? An acid catalyst, or a strong acid, not an acid catalyst but an acid, an alcohol in the presence of an acid, this will dissociate or will undergo what? Dehydration to produce an alkene and water. Okay, so we can see that this reaction is reversible. So let's go ahead and look at how this reaction occurs. So we have our double bond or our alkane over here. Okay, and so in this case I am using this carbon over here. Let's assume this carbon with the asterisk over here is our most substituted carbon, because this hydration reaction goes via what? The Markovnikov addition in terms of what? Regiochemistry. So if we add water in the presence of what? An acid catalyst, okay, what do we get? Okay, so let's write the mechanism for this. So the mechanism is water in the presence of an acid produce what? H3O plus or hydrogenium ion, which is the strongest acid you can get in solution. So if we have our alkane now reacting with what? H3O plus. Okay, so water, okay, in the presence of what? An acid can be rewritten as what? H3O plus. Okay, it's still the same thing. Okay, so if this happens, the water over here, the alkane, the double bond over here will what? Pick up a proton, and then the bond between the oxygen and then the hydrogen over here will break, releasing the electron onto the oxygen over here, thereby releasing or neutralizing this charge. So if this happens, this is what we get. We get what? The alkane, this. Okay, the hydrogen will be attached to the less substituted carbon over here, which is this one. Okay, this is the most substituted carbon with the asterisk. Okay, so once that happens, we can see that this carbon is now having what? Just 3 bonds, and hence it is short of what? It is short of one extra bond. So let me use another color to indicate that. So once this carbon is short of an extra bond, it becomes what? A carbocation. Okay, because this carbon is the most substituted carbon over here, this carbocation is very, very what? Stable. Okay, then we have what? Water also in the reaction. Now after we have the protonation of the double bond, we have the nucleophilic attack of water. So which means the water over here, the lone pair on the oxygen, one of them will be used to attack the carbocation. Okay, thereby producing what? A protonated alcohol. So we have this as our protonated alcohol. So we have our oxygen having what? two hydrogens with what, a positive charge, then we have this. So this is what we are calling the protonated alcohol. So once we have the protonated alcohol, the third step is what, the deprotonation of the what, the protonated alcohol to give what, our what, alcohol. So it means another water molecule, okay, the electrons, the lone pairs on this oxygen, one of them will pick this proton over here, releasing the electrons onto this what, oxygen. Okay, so we now have what, our alcohol, okay, produced. So this is our alcohol or our product that we are forming. So this is how the reaction occurred. So let's have a look at a real life example to actually appreciate what we are doing. So the first one we want to look at is the acid catalyzed hydration of what, propane. So propane, this is how propane is. This is propane. Okay, so we are adding what, H3O plus. Let me go straight. So we are adding water in the presence of an acid, which is now H3O plus that I've written over here. Okay, so in this example we can see that this carbon bearing the double bond over here, this particular one, has what, one alkyl group attached and then one hydrogen. This other carbon has two hydrogens, so which means this carbon is the most substituted carbon in this example. So it means the OH has to be attached to what, this most substituted carbon. Okay, so from here, when the double bond attacks the H3O plus to pick a proton, releasing the electrons onto the what, the oxygen, the hydrogen over here is now attached to the what, to the less substituted carbon, because we are saying in terms of regiochemistry this reaction goes by what, Markovnikov's addition. So we have our hydrogen, C, carbon having the hydrogen with the CH3 here, then we have the second carbon with the hydrogen here, then the proton being picked from the H3O plus is the one that we have over here. So we have a carbocation formed over here. So we can see that this is what is a secondary carbocation formed over here, secondary carbocation. Now if we were to form the carbocation over here, we can see that this carbocation, this carbon is only attached to one carbon, so it will be what, a primary carbocation, which is not stable. Okay, so now that we have a more stable secondary carbocation, another molecule of water with lone pairs will now, one of the lone pair will attack the carbocation that we have to produce what, our what, protonated what, alcohol. So we have the CH3 here with the carbon having the hydrogen, then we have our O, then attached to H, and then H with the positive charge over here on it, and we have our second carbon with the hydrogen over here. So from here, another water molecule, okay, will now come and pick a proton, releasing this bond, these electrons onto this carbon. Hence from here we now have what, our alcohol, which is this OH with what, CH3, which is this one over here, plus what, the H3O plus that we obtain from what, this water picking a proton over here. So this is our alcohol that we produce, and then this alcohol, this is 2-propanol. So it means when we react what, propane with what, water in the presence of an acid catalyst, we get what, 2-propanol. So let's have a look at what, another example. So the second example we want to look at is, we have this alkene CH3 bonded to what, CH3, then we have double bond C, H, then CH3, then we are adding water in the presence of what, an acid catalyst. Then this is our product that is being formed. We have CH3 here, OH here, C, H, H, CH3 plus what, H3O plus. And then the question is asking us to write the mechanism for this reaction. So assuming I've not given the product over here, because we are reacting an alkene with water in the presence of what, an acid, we know that this is a hydration reaction, and for hydration the OH, okay, has to be added to the most substituted carbon, which in this case is this carbon over here. So we can see from the product that the OH is added to the most substituted carbon, and then the hydrogen to the less substituted carbon, which is this. Okay, so let's write the mechanism. If you feel comfortable or you think you can write the mechanism, you can pause the video and write it, and then unpause it, and then we continue. Okay, but for those of you who are not confident yet, let's write the mechanism. So we have our alkene over here, CH3 doubly bonded to this H, and then CH3 over here. So water in the presence of what, an acid catalyst, will be what, H3O plus, which I'm writing like this. Okay, so the double bond here will pick a proton, releasing these electrons onto the oxygen over here. So we have this. So because this is the most substituted carbon, the hydrogen picked, or the proton picked over here, will attack the less substituted carbon. So we have this CH3 here, CH3 here. Okay, then we have this with the hydrogen, then CH3 here, then with the new picked proton over here, then we have the carbocation being formed over here. So we can see that this carbon is attached to 3 other carbons. So what it is, what, a tertiary carbocation, which is very, very stable. So from here, water molecule from the solution with the lone pair will now attack this carbocation, or the carbon bearing the positive charge, to produce what, our protonated what, alcohol. So this is how our protonated alcohol will look like. We have CH3, then the water that is attacked will now have OH with a positive charge from here, and we have C H, hydrogen over here, H, then another hydrogen, then with what, CH3. So water again will now come with its 2 lone pair. We will use one of them to pick the proton, releasing these electrons onto the oxygen over here to produce our alcohol. So this is what we are going to get at the end. So we have our OH over here, then we have the carbon, the hydrogen over here, CH3 over here, then we have the hydrogen over here, plus H3O plus in solution. So this is our product as requested from us by the question. All right, let's have a look at one final example. Now this example is the most the one that I actually want to show you guys, because it is very, very interesting. So let's have a look at something. So we are reacting 3,3 dimethyl 1-butene with what, with water in the presence of what, sulfuric acid H2SO4, that is 50% H2SO4. okay, and then the products that we are having, this reaction leads to what, 2 products. Okay, so we have 2,3 dimethyl oh sorry, this is not supposed to here, butan 2-ol. Okay, so it means we are producing an alcohol. This is the major product, and then the minor product that we are forming by reacting this is what, is 2,3 dimethyl 2-butene. So this is our minor product. So it means when we react 3,3 dimethyl 1-butene with water in the presence of what, 50% H2SO4, we get a product such as what, 2,3 dimethyl what, butan 2-ol as our major product, and then we also get what, 2,3 dimethyl 2-butene as our minor product. Now the question is asking us to what, to write the mechanism, how come an alcohol and then another alkene is produced from this reaction. So let's go ahead and write our mechanism. So first of all, let me get rid of everything on the slide over here, and then let me use black for the demonstration. So for our starting material, which is the 3,3 dimethyl 1-butene So this is the structure of what 3,3 dimetal 1-butene. So we have this attached to another carbon, then CH3 again, then we have C attached to what hydrogen, then doubly bonded to what CH2. So this is our 3,3 dimethyl what 1-butene. So we are reacting this with water in the presence of what H2SO4. H2SO4, that is 50% of it. And then the product that we are having are what the 2,3 dimethyl butane 2-ol, and then the alkene. So let's write the mechanism for this. So first of all, the alkene that we have over here, CH3, C, CH3, CH3 with C hydrogen, then double bond CH2. Okay, the sulfuric acid will now react with it, or will protonate it. So we have this is how sulfuric acid is written. So we have OH. So this is partially positive, this is partially negative. Okay, so the double bond will pick a proton, releasing the electrons onto this. So if that happens, we can see that this over here, this is our most substituted carbon in this case, because it is attached to one other carbon over here. Okay, so it means the hydrogen being, or the proton picked over here, will go to this carbon. So we have what our CH3, C, CH3 at the top, CH3 here, then we have it over here, then we have the hydrogen over here, then singly bonded to what the CH, and then H, and then the proton we picked over here is coming to this carbon, so it is over here. So it means we are forming a carbocation over here. Now let's look at something very, very interesting. You can see that this carbon over here is attached to two other carbons, so this is a secondary carbocation. Now let's look at this carbon. This carbon is attached to 1, 2, 3, and 4 other carbons. So it means what, there is the tendency for this compound to produce what, a tertiary carbocation, which is more stable than what a secondary carbocation. So once there is that possibility, this reaction will automatically, okay, undergo a rearrangement reaction to produce what, a tertiary carbocation, which is what, more stable than the secondary carbocation. So from here, what will happen is we have one of the methyl groups over here will now come and attack the positive center over here, thereby making this center to become positive. So we have what, something we call methyl shift. Okay, so we have methyl shift. That is what, this methyl over here will now attack this center. Now once that happens, we have our CH3 bonded to C, CH3 at the top. Now this center becomes what, the carbocation. Then we have C. Then the methyl that has moved over here is this one that I'm writing over here, and we have the hydrogen at the top, and we have C, this one over here, then hydrogen, hydrogen, hydrogen. Okay, so this is now what, a tertiary carbocation, because this carbon is attached to 1, 2, 3 other carbons, so it is very, very stable. Okay, so once we have the tertiary carbocation, from here water can now come and attack this center. Mind you, we have the tertiary carbocation plus what, HSO4 minus in solution. Okay, so we have water also in solution. Okay, now let's look at something. Now the H2SO4 is a strong acid, so this over here, the anion that is formed from losing a proton from the H2SO4 is a what, is a weak base. Because this is a strong acid, its conjugate base is a weak base. Now in the presence of water and this, water is a stronger base than what, than the conjugate base of the what, the H2SO4. So the tendency of what, water attacking the carbocation to form an alcohol is much greater than what, the conjugate base over here picking up a proton over here to form an alkene. Okay, so if 3 of the water molecules attack the proton, the carbocation over here to produce what, to produce an alcohol, it means when 3 of the water molecules attack, one of the H2SO4, which is the conjugate base, will not pick a proton to produce an alkene. So the ratio can vary. It can be 3:1, 4:1, but then the key point over here is what, water, the possibility that water attacks this carbocation to form an alcohol is larger than what the conjugate base over here picking up a proton to produce an alkene. So let's look at the first scenario. The first scenario is what the most likely scenario that is bound to happen, that is water will now what attack this carbocation to form what a protonated alcohol. So if that happens, this is what we are going to get. Then we have OH over here with the positive center. Then we have CH with CH3 here. Then I'm writing this side as what CH3. So once this happens, we have what water in solution again. We have once this happen, we have the HSO4 minus, which is in solution, will now come and what pick up what the proton over here, releasing these electrons onto the oxygen over here. So from here we will get our product, which is what CH3, CH3. Then we have just what OH from here, OH. Then we have CH3, CH3. So this is our major product, and this is what the question is given to us as what. This is our major product, and that is the compound 2,3-dimethyl butane 2-ol as our major product. Okay, so now let's look at the possibility whereby what the HSO4 minus will now pick a proton to produce the alkene, which is what the minor product that we are talking about. So let's start again. That is from where we have the carbocation, and see what happens before we get our alkene. So if this is our carbocation, the tertiary carbocation that we formed earlier, CH3 with the next CH3. Okay, if this the conjugate base that we have over here picks up the proton over here, okay, because this is a positive center, it makes this carbon over here partially negative. Okay, so it means this proton over here, or the hydrogen over here, is slightly what acidic. So it means the tendency for this conjugate base to pick this proton is also high. So once that happens, it means once this picks up the proton, these electrons will be what will be released onto this carbon. So this is what we are going to get. We have CH3, CH3 over here with a positive center over here. Then we have this. Then we have the lone pair of electrons on this. Now we have CH3. Then we have another CH3. Okay, so because we have the lone pair over here, this lone pair will now come and what form a double bond over here. And so once that happens, we have our carbon, and we have CH3, and we have the double bond CH3, and then CH3. This is our minor product, that is being formed from the reaction, and this is what we are calling what our 2,3-dimethyl what but 2N. So this is our minor product. So thank you so much for watching. I hope this tutorial helps you understand how we do what hydration of our alkanes in the presence of what an acid catalyst or an acid. So thank you so much for watching once again, and I'll see you in the next video. Until then, keep safe and then keep studying chemistry. Bye bye.